This air compressor consists of an electric motor that compresses air into a storage tank. The compressed air can be released at chosen pressure when required. How works an air compressor? What are the criteria for selecting a proper air compressor? Well, there exists a variety of different compressor types. Let's continue with an overview. Normally, the compressors used in the field of automation and workshops are the outlet or discharge valve opens at high pressure during the compression strike. Air heats up when it is compressed. This is a problem of each compressor. The result is not only a less efficient compression cycle, but also to a real danger of explosion if any inflammatory substances, such as oil or lubricant, get contact with the overheated air and piston. Therefore, the compression of a single-stage compressor is limited to an output pressure of about 10 bars, or 145 psi. To achieve higher pressures, you would use a multi-step compressor. Here, a two-stage compressor is shown. The large piston builds the first stage. The air leaving the first stage can now be cooled before it enters into the second stage. With a two-stage compressor, you achieve pressures over 20 bars or 290 psi. Multi-stage compressors with high power also can use water cooling to avoid overheating. Based on its working principle, the reciprocating compressor delivers only pulsed compressed air. Therefore, this type of compressor is used in conjunction with a tank. However, the use of a tank offers the advantage that the compressor can be operated with a two-point controller, resulting in less energy consumption and wear. The diaphragm compressor belongs to the family of the piston compressors. Here, the suction chamber is sealed from the piston by a diaphragm. As an advantage, the compressed air in the compression chamber does not come in contact with the lubricated piston, and thus can be kept free of oil. The weak point of a diaphragm compressor, in general, is its membrane itself, since the elasticity is limited. You would use the diaphragm compressor, for example, in the food industry or to fill divers' bottles. A totally different working principle has the so-called rotary compressor, also named as vane compressor. The typical rotary compressor has a cylindrical housing. Adjustable rotary vanes with its center point on an offset drive shaft have contact with the housing. So when the shaft rotates, these vanes create chamber of variable sizes. Air is sucked into the largest chamber, being compressed, and leaves the compressor at the smallest chamber. Advantage here is in the pulsation-free flow, in contrast to piston compressors. Therefore, an air tank may be optional. In addition, these compressors are quiet and relatively insensitive to dirt. Typical applications are, for example, wastewater treatment, fish breeding aeration, dust collection,